doing. Oh, recording in progress. That's spooky. I am briefing descent planning, which is from my research of it a pretty technique heavy concept. I found all the things I could find on like what the procedures require you to do, and then I think everybody kind of has their different ways of executing that. So I took snippets of all the different pubs that tell you what you have to do, and then I threw in kind of here's what I do or what I've seen other people do. Just for co-pilots or people that have only been flying Fred for maybe a year or so. One of the hardest things I think coming to the C5, at least for me and for a lot of people, is descent planning and descending in the C5, just because it really doesn't like to slow down and descend at the same time. And so coming from other airplanes or coming from UPT, that isn't as much the case. And so now I think a lot of co-pilots are like, well, crap, what's the best way to kind of get this airplane down and configured and ready to land? So that's what today is going to be about, how to best do it and how you should do it. And I will now share the PowerPoint. Sweet. All right. So descent planning. Here's what we're going to go over. What do I need to descend? The weather to descend. Penetrations, just kind of in relation to descents. I went back a chapter in the Dash 1 and kind of grabbed some stuff about penetrations as well. How to descend, the procedures and the techniques, flitch versus vert speed and which to use. It's kind of up to you. There's also VNAV, but Leiter had already given his full brief on VNAV that was much more in depth than I was going to go into. So if you want to use VNAV, that's also a third option that you have. Just kind of quickly talking about the level at 10,000 feet, just because I've seen a lot of in the last year kind of misnomers or people not fully understanding the leveling off and slowing down at 10,000 feet and thinking if you're at 10,000 feet, you have to be 250 knots, which isn't the case. You can be fast at 10,000 feet if they let you down there. And then talking about TRs, using them, should we not? Are we allowed to? When are we allowed to, etc. So first off, what you need to descend. In the Dash 1, the descent requirements are the pilot monitoring should get you the weather so that the FE can compute your told with the weather. And then with that told, you do your brief. And then that's one of the first steps in the descent checklist is your brief. So if you look at the little snippet that I put down there, that's the full verbiage out of the Dash 1. And it tells you that the forecast data that you get in your papers or from the box can be used to get your told. You just have to make sure to get an actual updated ATIS or something like that to make sure that those numbers are right. And then like most of us do, it says right in there that you can do your crew briefing prior to calling for the checklist so that when they say crew briefing, you can just say completed instead of starting it right there and then kind of taking a big pause in the middle of the checklist. So those are the things you need really, the weather, you're told, and then your briefing to kind of get started. So now that you've got the weather, can you descend? Well, as you'll remember from pilot training, there are a few things that you require. Obviously, ATC telling you time to descend or you asking them for clearance to do so. But to begin the descent, this is out of the 202 Vol 3 and the 2C5 Vol 3 for the weather that you need to be able to descend or to try to start an approach. A lot of the time, you'll see highlighted on here. You just need at or above required viz for your straight ins or your side steps. And then minimum RVR for Cat 2s is 1200. So in reality, unless the weather is really, really bad, you will likely be able to start a descent and kind of see if the weather is really what it is being called. And I won't get too far down into approaches and stuff like that because this is really just descent planning. But obviously, you don't want to start a descent and waste all your gas if the weather is telling you the viz is 0, the ceiling is 50 feet, because then you're just wasting your time. At that point, you should be diverting. But this is straight out of the 202 Vol 3 for what's required, viz minimums for straight ins, and then ceiling in viz for circling. And so it kind of says the exact same thing right in two pubs. It's a good case of pubs agreeing with each other instead of us kind of being like, well, this pub says this and this pub says that. Which one do I listen to? This is pretty clean cut. So just make sure that your weather supports an approach before you descend. I think sometimes we just get a little ahead of ourselves. And I have seen it in the past, and luckily other pilots have caught it, where people were like, all right, time to descend. And it was like, well, we don't have the weather for an approach. So why are we going to do a descent? So all of that is just in preparation for your descent planning should you be descending. Penetrations, I also stole out of the Dash 1. It's the section right before descent, 2.29. Descent is 2.30. I just wanted to point out this warning. To provide adequate margins above stall, configured penetrations shall not be initiated at altitudes above flight level 200 and at gross weights above 600,000 pounds. So that is important because I will reference later, hey, maybe I want to configure earlier than normal because it'll help my descent, but you can't just configure at 35,000 feet. And this is why. So really the maximum that you would ever see someone configuring the C5 at is 200. I've never seen someone configure that high, but this is where those kind of limits are listed in the Dash 1. So descent 2.30 in the Dash 1. En route descent and descent to initial penetration altitude. Sorry, the Cisco thing is in the way. There we go. Couldn't see my own presentation. En route descent and descent to initial penetration altitude is accomplished by retarding the throttles with landing gear up, flaps up, thrust reversers retracted, and descending at speeds within the speed envelope. Below 10,000 feet, maintain 250 knots or less unless otherwise directed. So that is a normal descent. Idle, gear up, flaps up, thrust reversers retracted. So clean jet, idle, descent. That's what the Dash 1 says is our normal descent. And then the Vol 3, Chapter 11 under fuel planning, there's also a blurb in there about in-flight, such as climb and descent profiles and power settings should be considered for efficient fuel usage. Constant descent arrival should be performed when able. So basically, and that makes sense as well, you don't want to just dive to a cleared altitude at idle and then push the power back up and bring your speed back up to 300 knots and then dive again, just because all of that throttle movement is going to burn extra fuel. So with all that said, I kind of threw my blurb at the bottom. So with that, I'll just idle flitch to any altitude I'm cleared, and ATC will get me down in time, and I'll be good. And the issues with that line of thinking is, one, they might descend you way too early, and if you've done good descent planning, you'll know they're descending me way before I need to. Let me descend slowly, maybe 500 feet per minute. And we'll talk about why 500 feet per minute is really the slowest you want to be descending. Or two, they might not be descending you early enough, and then you've got a dangerous or unstable approach because you're being slam dunked. I think most of us who have been in the C5 have seen that before, especially at Rota or other places where they're slow to descend to you. If you have good SA on, hey, I should have descended 10 miles ago, let me bug ATC about trying to get a descent now. You being on top of that instead of just being at their mercy might help you not have to go around or do a 360 or ask for extra vectors. And so if I'm telling you that, how do you keep track of when you should descend if you can't just trust ATC to do it for you? The procedures don't make you descend one way or another. If you follow the prior rules that I kind of picked out of the Vol 3 and the Dash 1, then you're good. So there's some different helpful tricks that I've been taught and I've seen other people do. And I tried to kind of encompass them without getting too deep into the math. So as a good guess, just to start off at a very easy baseline for how much you should be looking to descend, if you take your nautical miles per minute, so your ground speed divided by 60, and you can round just to make the numbers easier, and then you multiply that by 3 and then 100 to get feet per minute, you'll see at the bottom I did descents between 360 and 500 knots for ground speed, because it's based on different winds or how fast you're going and calibrated. It could be anywhere between those two. So divided by 60, that gives you a range of between 6 to a little over 8 nautical miles a minute. And if you multiply that by 3 and then 100, you'll get between 1,800 to 2,500 feet per minute descent for a baseline. And I just pulled out of the PowerPoint really quickly just because it looked like there was a chat, but maybe there was not. Okay, cool. I'll continue then. So 1,800 to 2,500 feet per minute is a pretty good baseline for, hey, how much should I descend if I haven't done any math and I don't know? A great way to visually see a constant descent arrival, like the Vol 3 for fuel planning talks about, is to literally draw on your displays a 3-degree and a 4-degree glide slope to the field that you're going to. You can do that by going to the init ref page. I think it's page 3, and then going to the fix page and putting a nav aid that's on the field in your fix. And then if you calculate the altitude that you need to lose, so your current altitude subtracted by whatever the field altitude is, and multiply that by 3 or 4, I put in parentheses there, add 10, just for a slowdown and for some lag. If you plug those into the fix pages for distances, you can now draw a 3-degree glide path and a 4-degree glide path zone and kind of keep yourself up to date with where you're at. I'll kind of show you how that looks in a second. So here's an example of exactly what I'm talking about. So we have this approach plate for Colorado Springs. The field elevation is just over 6,000 feet. And for the example, you're at 360, you're planning to land here, and you're trying to draw your 3 and 4 degree range rings so that you have SA on when should I descend. So you take 36,000 feet, your current altitude, and you subtract 6,000 feet, because easy math. You don't need to be super exact when you're in the jet trying to do this. Gives you 30,000 feet of altitude you need to lose to get down on the ground at Colorado Springs. So if you multiply that 30 by 3 and then add the 10 that I talked about for slowing down, configuring, etc., that gives you about 100 miles out is when you would want to start an easy descent for a 3-degree glide slope. And then if you do the same thing for 4 degrees, you multiply it by 4 and add 10, you get 130 miles out for 4 degrees. So if you plug maybe the tack in or another nav aid on the field in your fix page, and then you give yourself a distance ring of 100 and a distance ring of 130, it's going to draw that nice green dotted line, and you're going to see 2 of them with a big gap in between. And if you descend somewhere in that range in between there, then you're going to be set for an easy descent. And the nice thing about that is if you get intermediate altitudes in between, let's say, hey, they descend you to 250, you can now just redo that math really quickly. So 250 minus 6,000 feet, add 10 to each of those, you can just throw those two new numbers into your fix page and see how your descent is coming as you get lower. You can just constantly update it. And then if you make sure that the altitude intercept arc or the green banana as you're in a descent is showing that you'll be level at 25,000 feet, either in or prior to the updated range rings that you've made, then you know that you're on a good descent profile to stay descending at a constant rate. So those are the range ring methods. What if ATC decides to slam dunk me into a field and all of the math I just did was for nothing? Am I still going to be able to make it, and how do I know? So this has happened to, I'm sure, most of us. You do this nice math, you ask for a descent, they tell you they can't because there's a mountain range or there's traffic or whatever, and you're well past where you wanted to descend despite keeping on top of it. I'd like to do a little 3-3 tactical descent approach math for my worst case descent so that in the back of my head I know as I'm getting closer and closer, am I still going to be able to make it, or am I going to need extra space or something to get me down in time? And so this is straight out of the 3-3. I kind of highlighted the numbers that I use personally because most people are descending at the top clean at 300 knots, and then a slowdown from 300 to either 230 or to 180 is generally what people do. I also did level slowdowns at 20,000 feet. That's based on 20,000 feet in the Dash 1 is kind of the warning for the highest you can start a penetration. So I'm generally not slowing down that high to try and configure, but that takes the most distance. So I use that number because it gives me the most conservative number. If I do it lower than that, it should take me less distance. And again, this is for my worst case kind of guess math anyway. And then 13.5 miles is how long it should take you to slow down from 300 to 180 at 20,000 feet, according to this table. And then lastly, how much distance will it take you to descend configured? About 1.25 nautical miles per 1,000 feet at 600,000 pounds. So again, I'm using worst case scenarios as much as I can because this is my WAG math for if I hit this number, I'm worried about being able to make my descent into the field. So now I need to do something or ask to do something. And all of this obviously assumes that, as you see on the bottom of this note here, your idle, your flaps 100%, and your speed is 175. Flying at 165 results in a 10% increase in the distance it takes. So this is the truly like tactical best case that the C5 can get down. So depending on the weight, it will take you between 2.3 to 2.9 nautical miles per 1,000 feet you need to lose at 300 knots. And that is from this chart at the top right here. You'll see the 300 knots is highlighted. So at 500, 600, and 700,000 pounds, it takes either 2.3, 2.6, or 2.9 nautical miles of distance to lose 1,000 feet clean at 300 knots. So I just round up the worst case scenario for easier math in the jet, and I use 3 nautical miles per 1,000 feet. So once I've descended at 300 knots clean, I need to slow down to configure. So 300 to 180 to fully configure at 20,000 feet, the highest that you can configure that takes the most distance, because again, I'm trying to do worst case math. The chart tells you that it takes 13.5 nautical miles. So again, easy math, I use 15 because I'm just trying to calculate this quickly in my head, and I want some wiggle room for winds, or maybe I'm a little heavier than the chart says. And honestly, I don't want to be doing a full tactical descent into a field on a normal day anyway. And that number is at the bottom of this chart. 20,000 feet, it's highlighted in that box, 300 to 180, it tells me we'll take 13.5 nautical miles. So like I said, I've rounded that up to 15 for the example. And lastly, now that you've configured, you've descended at 300 knots clean, you've slowed down to 180 knots, you're configuring, you need to get down. So it says that it takes 1.25 nautical miles per 1,000 feet of altitude you need to lose once you have configured. And that is from right here. So that's at 600,000 pounds, steep straight in, fully configured at 175 knots, which again is not ideal for every day. Looking at how this would all work on that same approach into Colorado, you're at 360, you're planning to land 17 left again. It's the same field as before. You'll descend at 300 knots from 360 all the way down to 10,000. So you have 16,000 feet that you need to lose. So you go down, like we said earlier, it takes 3 nautical miles per 1,000 feet. So 16,000 to lose. Oh, I'm sorry. Times 3,000. 3 nautical miles per 1,000 feet. I'm getting confused by my own numbers now, which is unfortunate for me. Sorry. 3 miles per 1,000 feet. So I think I did the math wrong, is why, on the slide. So you have 16 to lose. Good live, me messing up my math. Which is why I try to use easy numbers, and then it still doesn't work. So you have 16,000 feet to lose.
48.
48, yeah. So I typoed the 1 there. Thanks. Asper, I think, maybe. So that should say 48, not 18. Sorry to those of you that are reading my bad math. But the next part, now that I'm at 10,000 feet, I need to slow down. So I slow down to 180, and that, like we said earlier, that's just straight off the table. So I couldn't do that math wrong, luckily. Will take me 15 miles to do that. And then to descend to 6,000 feet, which is the field elevation, from 10,000 feet, which is only 4, takes, like we said from the table, 1.25 nautical miles. So that's 5. So the 48 plus 15 plus 5 is 68, not 38 down there. So 68 miles or 70 miles from the field, if I am still stuck at flight level 360, I'm going to have a problem landing, because that's kind of the worst case scenario that I can get down. So if I can even get down a little bit from that, I can kind of redo this math and see, okay, what's the closest I can be to the field at my new altitude that I'm going to be able to like max descend. Obviously, your goal is to try and do the level descent, the constant descent, like the -1 and the Vol 3 ask you to do for fuel planning. But this is your actual like worst case scenario. And I'll fix this slide before I post it, so that if anyone wants to relook at how it works, they can follow it better. So now that we've talked about all the different techniques for descending, do you use flitch or do you use vertical speed? What are kind of the pros and cons of one versus the other? It's totally up to you. The -1 doesn't tell you have to use one or the other. Just know what the difference is, because I've seen in the jet people who use one method or another, and then when they're asked like, hey, like, why aren't you using flitch or why aren't you using vert speed? They don't really know. They will just kind of say, oh, I don't know, like someone taught me this way. And that's fine. Like, you can use either. And I've seen instructors, even evaluators, that use one or the other in different scenarios. And so the more you kind of understand how they work and what you want, the better option you'll likely choose. So just knowing the difference and knowing your situation will lead you more likely to pick one versus the other. So here's what they do. Flitch, this is out of the -1. So flitch, during extended descents, the auto throttle is going to move back to an idle position. And the autopilot is going to pitch down to a programmed vertical speed for a small descent, which basically just means if it's not a large descent, it's just going to pitch down to capture an alt cap and then an out hold. If a more extensive altitude change, it's going to go idle, and then it's going to maintain whatever you have in the airspeed command, which the second you hit flitch, it's going to throw in there the speed you're at. So you need to hit flitch, and then you need to decide, okay, what speed do I want to be descending at? Most of the time, you should be descending at 300 knots. It's just the typical descent. So once you change the speed in the speed select window during a descent, after you've hit flitch, it'll pitch the airplane to achieve that new speed. So basically, in summary, flitch is going to focus on the speed, and it's going to change your pitch and your throttle if it needs to achieve that speed. So in a descent, if you are below the speed that you set there, it's going to pitch you down heavily to capture the speed, which will give you a very high descent rate as it captures it. And then it'll pull the nose up once it achieves that speed to keep it, if that makes sense. So it's gonna drop down pretty aggressively at first to kind of gather the speed, and then it'll pitch up and descend you with the throttles at idle in a way so that it will keep the 300 if that's what you're commanding. And so this is really the best way to maximize an idle descent, like the Dash 1 asks you to do. It says that in a descent you should be idle, clean. And so this is going to give you the maximum vertical speed really down that you can get. For vertical speed, which if you don't need a maximum descent down, maybe you're ahead of schedule or you're before or just inside those range rings you just created, and ATC clears you the field, that might be a good time to use those WAG numbers of 1,800 to 2,500 feet per minute down and just start a simple 2,000 foot per minute descent and kind of update yourself and see if you're staying on glide slope. Because if you flitch 300 right when you're descended and you're ahead of glide path, you're just going to hit your altitude well before you need to. And a good way to kind of judge that is when you hit vert speed and you go 2,000 down and you're updating those range rings, like I said, if your altitude intercept arc or the green banana is showing you leveling off inside your 3 and 4 degree range rings, then you know you're on glide path. And so you might not necessarily need the full descent capability that flitch is going to offer you. The difference highlighted here from the Dash 1 shows the autopilot is going to maintain the commanded vertical speed because that's the mode that it's in. It's going to start off at whatever your current vertical speed is, and it can be adjusted up or down 7,000 feet per minute. In this mode, the auto throttles engage in speed mode, and they attempt to maintain your airspeed, but they focus on the vertical speed. They prioritize vertical speed over the commanded airspeed like flitch does. So in a descent at a commanded vertical speed, if you ask the airplane to give you a really heavy descent, even with the throttles at idle, if that's too heavy of a descent, it's not going to protect your speed. So you might get a check speed now because the airplane's speeding up past what you've asked it to be at, because it's like, I need to go faster if you want me to give you the vertical speed you've asked for. And vice versa, it can give you a stall or too slow of a speed if you were trying to climb per se, and it just didn't have the throttle to get you up to that speed. So vertical speed, different than flitch, is going to highlight your vertical speed, and it's willing to sacrifice your airspeed. And then flitch is kind of the opposite. But vertical speed doesn't give you really a max descent. And so in a situation where you're feeling slam dunked or you really need to get down, flitch is usually your better option. When you're kind of on glide path and keeping up to date and really like paying attention to where you're at and you're ahead or on schedule, vertical speed is often an easier thing to use to kind of just keep you descending at the same rate that you want. Lastly, the level at 10,000 feet thing that I said I would bring up. The 202 Vol 3 and the AIM. 202 Vol 3 says do not exceed 250 knots below 10,000 feet. MAGCOMs may approve operations exceeding 250 below 10. And then going into the AIM, the section listed here, 4410, section D. If at any time the pilot is unable to climb or descend at a rate of at least 500 feet a minute, advise ATC. If it is necessary to level off at an intermediate altitude during a climb or descent, advise ATC, except when leveling off at 10,000 feet on descent. So the reason I'm highlighting that is I've seen before, you do not have to slow down your descent as you're getting towards 10,000 feet. You can descend at 300 knots idle and then hit altitude hold and slow down to 250 knots all right at 10,000 feet if you need to. It'll help your descent profile to get down a little quicker to do that. That's kind of the only time you're allowed to just level off without having to let ATC know. It also talks about IPs bring this up a lot, so it's a good thing to know where the reference is. The 500 feet per minute, when you're asked to climb or descend, that is the minimum rate that you should be climbing or descending at. And so they'll bring that up if your speed is really far away from what you want it to and you hit flitch. Like I said, flitch is going to sacrifice your pitch to achieve that. So you might hit flitch and the airplane's going to level itself off to slow down. And so momentarily that's fine, but if you have a lot of speed to lose, you might find yourself leveling off for a full minute, and an IP might be like, hey, are we kind of legally allowed to be doing this right now? So a better, if you really need to slow down at some point, technique might be to give yourself vertical speed of 500 down or up if you need it, wherever you're climbing or descending, and then plugging in your speed and bleeding off your speed at a 500 foot per minute descent, because that's technically, I love saying technically during something. It makes me sound nerdy, but that's technically what the AIM requires you to do, unless you tell ATC, hey, I need to level off to slow down really quickly, and most of the time they'll let you do that. The technique that I've been shown that a lot of people I think know about, descending through 10,000, if you are on glide path or early, right at 12,000 feet, if you're descending at 300 knots, you can set your command speed to 250, set your vertical speed to about 1,200, and it just kind of works out from people playing with it that in that 2,000 feet above 10,000, the airplane slows to right about 250 knots as you're descending through 10. And then if it doesn't work because of winds or whatever, and you're getting ready to pass through 10,000 feet and you're 25 knots fast, you can just hit altitude hold and finish your slowdown there. And this is where in the pubs it makes you legal to do so. And then lastly, TRs. I've never in the airplane seen anyone use them. Those who have been around longer than I have talk about it all the time in the B model days. They talk about it in the -1 in rapid descents. Rapid descents might be required in response to air traffic control, tactical considerations, or emergencies. There are two procedures. One of them is with TRs and one of them is not with TRs. And it says the greatest descent rates are achieved by descending with the inboard thrust reversers extended, as you might imagine, because you've now got two engines that are giving you reverse idle thrust and causing a whole lot of drag. But we have a safety sup in the -1 as well that says, as highlighted at the bottom, the use of thrust reversers in flight is restricted to operational necessity only, which is pretty vague. Gives you kind of the decision of whether operational necessity requires it. But in situations that I've seen, people have decided instead to do a 360 or ask for vectors versus be like, we really need to make this descent, time to throw out the TRs and be the first crew from Travis to use the TRs in a descent in a while. So I haven't seen anybody use them. I would think twice about if you really need them, but just know you're allowed to. They are for operational necessity only. And now my long-winded brief with some bad math in one of the slides is over. If anyone has questions, it was very technique heavy, but hopefully it was helpful to some of you.
Hey, this is Hafter here. So I just want to talk about the TRs real quick because we've been talking about it from a tactical perspective. So like you said, the book is vague on what is allowed. So it says operational requirements, like is allowed to use them. So the way I would interpret that is like if you're on an operational mission and there is a reason to use TRs, then you can use them. And the reason that it's has all this safety stuff is due to mechanical wear, not necessarily it's going to fail on you in flight. So Ro, Fez, myself, and it might have just been the three of us. I can't remember if we had a fourth pilot. We used them going into Al Asad about 2 months ago. And it was due to being spit out off the highway, and they hold you at a certain altitude, and then you're only like a short distance from the field. So it saved us about 20 miles of ground track, and it would have made us fly, like you said, a longer pattern, like or 360 or something, which in the tactical combat environment is obviously not desired. So what I'm trying to get at is that people shouldn't be afraid to use them just because there's this safety sup. We've kind of developed a mentality of they're on the verge of not available. Like I didn't know anyone that's used them probably in 2 years prior to us using them 2 months ago. So I'm not saying you should use it every time, but if it gives you a tactical advantage, don't hesitate to use them because they have to do a fan blade inspection or whatever the inspection is. That's only once you get back to Travis as well. So it's not going to affect you like having to get an inspection on the ground in Al Asad or something like that. So if anyone more experienced has, probably some of the older guys have some more experience using them because they were used pretty heavily right when they came out before this safety sup kind of came out. So, but that's my thoughts on it from a tactics perspective. And I would not recommend doing it having never practiced it, and you can't practice it except in the sim. So if you guys are doing proficiency sims, I would recommend getting them to give you some scenarios where you can practice like a TR descent into like a Bagram or something like that. So
Yeah, I agree. I think it's definitely something people are afraid of, and I don't think they should need to be. I think using them in a tactical scenario like that makes a lot of sense versus just kind of flying around unnecessarily. But good point. I don't think a lot of us have seen it, and so a good place to kind of see how that all works would be in the sim. So I agree. Everything I read and everything I've been shown tells me that I can use the TRs if I need them. So I wouldn't say you should be afraid of them. They're basically, you just have to put a small write up in there for them to do an inspection. But from what I've heard from maintenance, it doesn't take them more than like 10 minutes. Cool. Yeah, sorry about my incorrect math on the one slide. Appreciate whoever shouted it out. Maybe it was lighter, I'm not sure. But yeah, pretty technique heavy. It's kind of a collection of everything I've been shown. Just the more kind of tools you have in your toolbox per se, the more stuff you can use or not use. I mean, whatever works for you. I don't necessarily do all 4 or 5 of the things that I showed you every time I descend. It's very situational, especially if I've been somewhere before. And that kind of comes with time. But any other questions, or if people want to talk about other things, that's totally cool. I'd probably beat
This Lieutenant Park, I have a question.
Go ahead.
I've been learning and practicing and using the decent where to start descent from to nav a point or waypoint to shoot an approach, the techniques that we have discussed, and I've been using it. And a thing just came across my mind is that when I was in college, the professor said, "Yeah, when I was flying airline, I put just FMS altitude for the next waypoint, and they would give me the top of descent point calculated for us. That's shown on the nav page on the MFD. So what's the difference between calculating our own technique that we've been using and having FMS to figure out and show it on the nav page? Which
Um,
one's more accurate?
so I don't know if I fully understand your question, Park.
So, okay, I'll rephrase it. So the descent planning technique that we use, and we calculate our own, get the ground speed, and get it multiplied by 60 technique, and then we draw our ring off the fixed page on a in ref, and try to have the green banana between two rings. So that's the technique that we've been taught and we use in our flight. And I also heard about another technique that I heard when I was in college that some someone told me that he just from cruising altitude he just put the next waypoint and the altitude to cross on the FMS. You know, you can go to you can have the next altitude for the next waypoint on your leg page, and then have the FMS to calculate and then generate a top of descent point on the nav page.
You're talking about in, I think, the legs page, or you're talking about putting like step down altitudes on different
Yes,
fixes that like are on your legs, or are you talking about trying to be at certain altitudes by certain like random navids? I don't know if I've actually seen what you're talking about.
I meant this. I meant the step down altitude for the approach that you put in.
So is that for an approach? Because
Yeah, that's for approach.
you don't have
Either.
step down
Yeah,
altitudes for a descent.
that's for the approach.
Yeah, so I that's a slightly different thing. So that would be in the legs page, you building an approach and then calculating a best descent to meet step down fixes. Is that what you're talking about?
Yeah.
Hey, this is
Sorry.
Zach,
That's
and I
wording.
think what he's saying is that maybe like with airlines, they have for us we have like a discontinuity before our approach, but in the airlines they might have built the approach towards the end of their legs. So if they put in the like final step down point altitude they need to for the final approach fix, then it'll back it all the way up to their cruising altitude and tell them when they need to begin their descent to reach that approach fix. Is that what you're saying, Travis?
That's correct. Sorry about the bad wording.
That's okay. There's a lot of instructors in here who can correct maybe something they do that I haven't seen, but I generally see, for the most part, people plan for a descent and then plan for an approach, not necessarily separately, but I haven't seen people talking about like meeting their step down fix altitudes on like a localizer or something like that when they're at 36,000 feet as part of that initial descent. I've kind of generally seen, hey, like there's a step down fix right at the initial approach fix, maybe that like I need to be at 10,000 feet, 17 miles out for whatever approach I'm doing. And so to get there from cruise altitude, I'm going to do this. But I haven't seen them plan all the way through a full approach as part of their descent necessarily. We can use VNAV and stars. Yeah, sure, that is true. So that is slightly different as well. This is all very. Ben is typing. Yeah, I mean, I just personally haven't seen people do that. I used VNAV on a star, worked like a charm. Yeah, so guess what you're probably asking, like the most similar thing we have to like something that the airlines would have or that you learned in school would be like Ben gave his briefing about VNav. Like you can plug in like altitudes at different legs and have VNav kind of give you a best descent profile and a time of descent for doing that. But that's kind of a separate thing unless you're specifically flying a star, which is some kind of arrival.
Hey Travis, it's Major Loftus. I get what you're asking in terms of utilizing the top of descent that the box calculates, and you can set the box up in such a way that it'll do that. It'll calculate your top of descent for you, and you can use that. And I would say you bring up a great point in the sense that Ben taught about VNav, and there's lots of different functions with the VNav. Some that work well, and then others that don't. And I think our tendency is to, most of us are just like, well, VNav doesn't work, so we don't use it. And so we don't necessarily always take advantage of some of the things that do work that help us out. So yeah, you could set it up like Ken said, and as long as there's no discontinuity, it would tell you what your top of descent should be based on the altitudes, because when you load the approach, it'll load those altitudes in the approach. So you'll have a top of descent point on your display on your MFDU all the time. Now, if you're flying along and you're 400 miles from the field and your top of descent point's coming up, then it's probably something's not correct in the box. But what I would say is I think VNav tends to work better, like Ben said, on stars, into major airports where it's like a very like regimented arrivals. Things don't get changed around and stuff. So when you fly into San Francisco, you're going to fly the same 3 arrivals every time, and they're going to keep you on that kind of common flow. Whereas, you'll be flying into Travis or you're flying into Ramstein and there's not a star or anything else like that. And so you try and build your approach and then they change the runway on you, or we just kind of have more of a like the fields that we fly to have a little bit more seat of your pants type feel to them, I guess you could say. Like you can build everything you want into the box for your approach into Bagram, but there's nothing standard about how you would arrive into Bagram as you come into the bowl. So yeah, on a perfect day where everything goes perfectly according to plan, I think you could use the top of descent in the VNav. And it's something that we could probably do a better job of bringing into our cross check of like, hey, like, is this a good time to descent? Like, yeah, the top of descent says it's time to go down, so let's go down. But then there's also fields where you don't get the descent that you want. People are talking about Incirlik and some of those other places where it's like, okay, so when I can't descend at the top of descent, like if I want to hit my VNav button and just descend, but something is restricting me from doing that, now what? Right now, how do I descend when the box is telling me I can't make the descent profile that VNav has built for me? So I certainly think we could do a better job referencing those pages and setting our box up to give ourselves the SA that we need. And I think for the most part, we've just come to this conclusion that VNav sucks. Hardly anybody, uses it for descents and stuff. The plan gets changed on you frequently enough that all the work that you put in to make sure that the box is appropriate kind of goes out the window and they do something different that you're not expecting. And then you end up, getting vectored or get descents or when you don't want them or too late or something like that. So it absolutely works. It's just a matter of making sure the box is set up appropriately and using it.
That answered my question. Thank you, sir.
Ken Sawyers again. I have another technique I was going to put forward that I learned from Captain Smith. So like you said, the 1200 VVI at 12,000 feet works really well if you're ahead of your descent profile or on glide path. But the one he gave to me was if you are behind your descent profile, you can keep yourself in flitch, descending at 300 and about 10,300 feet. You turn the speed to 250 and you'll end up crossing. It'll level the plane off and you'll end up crossing 10,000 feet right at 250, and then it'll continue its descent. So that's just if you're behind a descent profile.
And that is just because it takes about 300 feet for Flitch to pitch you up, and then you'll find yourself leveling in Flitch right at 10, I guess.
Exactly. Yes, that's exactly why.
Okay. Yeah, I've seen that before too. I think I've seen people do it pretty much right around 10 and probably be just underneath. But yeah, that's a good technique to keep yourself honest at not descending below 10,000 feet above 250. So thanks.
Hey, it's Lacey. Just a quick labeling question. So when you were talking about building your range rings, your descent rings on the fixed page, the 3 degree one, multiplying your altitude to lose by 3, yeah, that gives you a 3 degree. I don't think multiplying it by 4 gives you a 4 degree glide slope though. I think it's closer to 2. Because you're giving yourself more room to descend, so it gives you a more shallow descent.
Yeah, you're correct. I think it's like I think launch is right. I think it's closer to 2.5. It's a shallower descent.
Okay.
Multiplying it by 4. So yeah, thanks again with a catch that I'll fix before I post it. It's basically it builds you a kind of a threshold to try to meet a 3 degree or shallower glide slope down, which has the nav to do math. Yeah, so the point of kind of building the 3 and the 4 times, just in that threshold, you're going to be a 3 degree or shallower glide path, which is what you would prefer than a 4 or higher.
Yeah, this is Kimberly. I wanted to bring up something. This is not necessarily pertaining to descending, but something that I've noticed, like especially the younger pilots tend to miss, is that the flight level 200 at weights above 600,000 doesn't necessarily only apply on like descents. I've seen it come into play on climb outs. Mainly when it comes to like departing Bagram, we had a slats in transit and we were cleared above flight level 280. And the reason why the flight level 200 is kind of important to note is because that's generally the area where your Mach speed will start to come up or start to get pretty close to 0.45, which you can overspeed your slats or flaps without getting we had slats in transit, so we didn't get the red bar because of that. But it's something to note because we got all the way up to flight level 180 before someone in the cockpit caught it. And we actually were at 160 and then we leveled off at 18, which even then we only had like 5 knots of give or take. So I would say for those of you who are new to flying out, this is really much comes into play like in higher airfields, like I said, Bagram, where flight level 200 can come pretty quickly. If you have any sort of configuration issues, especially flaps or slats, I would probably say your hair should stand up a little bit if you're like climbing past 150. And still have the slats out because your Mach will start to creep up on you. And you can overspeed the slats pretty easily that way.
Cool. Thanks, Kim.
It's a blessing. One quick technique I have for descent planning for a descent rate. If you're planning on that 3 times your altitude to lose, basically your pseudo 3 degree descent rate there, you can just take your ground speed and divide by half and then times it by 100. So if you're going, ground speed showing 500 knots, divide that with 2, you get 250. So then you're looking at a 2,500 feet per minute descent rate, and that's your quick and dirty method. That only works for closer to the 300 feet per knock and looping. So you need to stick with that. Yeah. Hope that.
It's Major Blessinger. I've heard that one. I also saw someone posted the 16,000 at 60 miles. That's one I've heard. I tried and maybe did an okay job at not including every single technique I've ever heard of, but there are definitely a ton. And really, it's just up to you and what works best for you. Flitch at 10,300 to 250, or the 12 at 12 to get to 250, or Flitch vert speed, or VNAV, or I mean, there's really a lot of different ways to do this. Just trying to give you guys some of the ones that I've used, and Major Blessinger has that one, and 16,000 at 60 miles is another good check of whether you're on glide path to make it. So there's a lot of different ones out there.
Kim again. Another technique that I've seen recently that seems to help is instead of slowing to 250, to slow to 240, because the 250 is like your best glide in the C5, so it's actually harder to get down. So I've seen some pilots, though, instead of stopping at 250, they'll continue slowing to 240 to get below that, or to get below that peak glide performance in the C5. And I've seen them, it seems like they get down a little easier. However, I haven't done the math for it. I don't know if anyone else has or uses that technique.
Any other techniques, questions, things to add, to talk about? Will or Loftus, I don't know if you guys have something you want to discuss before we wrap up.
Hey, I'll just throw out there, the squadron's about to get real busy. So there's a lot of missions that are getting ready to stack up. So expect the schedulers to be calling. I say all that and you won't get a phone call and you'll be mad at me because you didn't get to fly. But I would just ask that you keep a really good eye on your currency. It's available on the SharePoint site. The SARMIs post it up every day, what your go and no-goes are and all that sort of stuff is. Big things that I'm concerned about for this quarter are proficiency sims and your group sims getting done. So obviously we had the sim down for the first half of the year. So we didn't get a lot of proficiency sims in the first quarter. So we had several people who just went non-current for their proficiency sim for not getting one in the first quarter, and we waived that. We waived it so that you could go fly. We didn't waive the actual number that you need done. So I would ask that you guys are diligent in working with the schedulers, that when you're not flying, that you are looking to get in the sim as much as possible. When we do these proficiency sorties in the sim, this is your time to try these different things, right? So I would challenge you to not fly your proficiency sims at Travis. There's some profiles that we're working on building to give you guys things to just be like, hey, can we go to this airfield and try this and do that? But this is the time to be like, hey, can I start at 30,000 feet and plan a descent into one of the like custom visual fields that are out there? And just ask your sim instructor. They should have a list of custom visual fields, but like Reagan National is one of them that works out really well. There's a bunch. They're out there. Hickam works as a custom visual field. So go explore in the sim and have some fun out there. But I'd ask that you stay up on your currency as much as you can as we prepare to get busy here in the next couple of weeks. We're doing our best to not waive the things that people have control over. So just stay diligent. And then I'll just echo what Major Bateman said today in all call. We've talked about it in officer development that we set the example out there on the road. And so just make sure we keep it professional and that we set the standard when it comes to adhering to the rules that are out there. Any questions for the training folks? Sweet. I don't have anything else. Y'all have a great weekend. Fly safe out there. I know there's like 4 or 5 missions leaving this weekend, so have fun. Enjoy the being locked in your hotel room with COVID. See ya.